So this lesson is going to be on the ozone layer, and here's your checklist of everything you need to know for that. So ozone is also known by the name trioxygen. So that means three oxygens. So the chemical formula is O3. So it's three oxygen atoms bonded together. It's found in the stratosphere, so we're in the lower atmosphere, which is the troposphere, and the ozone layer is in the part above that. So it's between 25 and 50 kilometers above the surface of the Earth. Why it's beneficial to us is it absorbs the harmful UV radiation from the sun, which can destroy living tissue. It can cause skin problems, eye problems, all of that. So we want to block some of that UV radiation from the sun. And in that stratosphere, in the ozone layer, it's actually only present in very small quantities. So there's only about 10 parts per million of ozone, in the stratosphere. So not very much of it at all. Therefore, we don't want to be creating its destruction. We don't want to be destroying too much of it. In this PowerPoint, what I've tried to do is separate things into the notes that you need to write down and that you need to learn, and into other information that it's probably not going to be asked on the exam, but it might help you remember some different things, or it's other information that's written kind of in the book and bits and pieces like that. So on the right here, it's a pungent, meaning smelly, pale blue gas, and it condenses into a very deep blue liquid. You can get the smell of it near photocopiers where there's electricity that kind of sparks a reaction between oxygen molecules in the air. Ozone is only present in the upper atmosphere. In the lower atmosphere, if there's a lot of it, it can be detrimental to health. It's known to aggravate asthma and cause bronchitis. So I've also tried to go through small bits in this video and then kind of go through the exam questions that would be asked on that. So far we haven't covered too much. You can be asked to remember the formula of ozone, which is O3, and the benefits of ozone, which would be that it absorbs harmful UV radiation and helps prevent skin cancer, or skin irritations, you could say. So more notes on ozone for you. Like we said, it's in the stratosphere and it's formed there. And it's formed by a reaction between an oxygen atom plus an oxygen molecule. So where do we get the oxygen atom from? Because we know oxygen, O, doesn't exist on its own. Where we get that from is when you take an oxygen molecule and it absorbs UV light, or it's broken down by UV light to form two oxygen molecules. This is called photodissociation. Dissociation is breaking down. Photo is anything to do with light, which can also be called radiation. So your definition for that is that photodissociation is the breaking of a bond using radiation. So you're breaking the oxygen to oxygen double bond in O2, and you're forming two oxygen atoms. So these oxygen atoms are also called free radicals. So what a free radical is it's an atom which contains an unpaired electron. So this unpaired electron is represented using a dot after the symbol. So you'll have seen that on the last slide as well. I've it highlighted here in blue. So these oxygen atoms are very reactive because of this unpaired electron. We know oxygen as O doesn't exist on its own, and that's because it's so reactive with that unpaired electron. So as soon as the free radical, which is the O dot there that we see in the reaction, as soon as they're formed, they will react with oxygen molecules, with O2, to form O3. As soon as this O3 is formed, it might remain for a little while, and it might absorb some UV light and prevent it from reaching the Earth. When O3, ozone, absorbs UV light, it can also undergo photodissociation. And what that is basically the reverse of that first reaction. So in the first reaction, you have an oxygen molecule plus an oxygen atom forming ozone. For the dissociation of ozone, the breakdown of ozone, you're just going to remake that oxygen molecule and that oxygen atom again. So those two are the exact opposite of each other. So you have the formation of ozone, which is the free radical plus the oxygen molecule, and you have the dissociation, the breakdown of ozone, which is going to just make the oxygen free radical and the oxygen molecule again. So some of the oxygen atoms can destroy ozone molecules. So the O free radical can actually react with ozone molecules as well. That's another reaction that could possibly occur. And what will happen there is that they're broken, they'll react together to form two oxygen molecules, so the 2O2 in purple there. And what that purple 2O2 will be used for then is highlighted there, the writing in purple. It will be broken down by UV light to form more oxygen atoms or free radicals, which will lead to the production of more ozone. So what we've seen from the last couple of slides there is that ozone is constantly being made, but it's also constantly being destroyed. So it's being made and destroyed and made and destroyed in a constant process. So we've three very important, two very important. On the last slide, those two reactions are very important. The formation of ozone and the dissociation of ozone. This is also another way in which we can produce more oxygen. We're breaking down ozone, producing more oxygen, which will then in turn be broken down to repeat the process on the last slide. So other information, it was thought that there was a constant amount of ozone in the atmosphere. However, in 1984, scientists discovered that the concentration over the Antarctic had decreased. And so it was known as a hole in the ozone layer. And there's also one in the above the Arctic. So we see that on both poles. And it occurs there because of the unique climate. Again, this is in other information. It's highly unlikely that this would be tested or anything. It's just for your information. So a few more notes. Ozone is not formed lower in the atmosphere, so it's not formed in the troposphere where we are. It's formed higher up in the atmosphere because down here there's a lack of UV light. And the reason there's a lack of UV light down here is because that UV light or radiation from the sun is already absorbed further up. So it obviously, the light from the sun coming towards Earth obviously reaches the outer layer, the stratosphere first, and is absorbed by molecules there. It doesn't make its way down here to the troposphere, and so oxygen down here is not decomposed in the lower atmosphere, so the reaction to create ozone doesn't take place. The main substance responsible for ozone layer destruction is chlorine. So chlorine atoms that are in the stratosphere are going to attack ozone. They're going to break it down. These chlorine atoms are produced by CFCs, chlorofluorocarbons, which we've seen mentioned a good few times, and I keep promising you that we're going to see more of them, and that is going to be the next and the final video. So how are they produced? CFCs are produced from alkanes by a substitution reaction. We're going to see more of that when we go back to chapter 23, but basically CFCs are carbons with chlorines and fluorines attached to them. So it's an alkane, so all single bonds between the carbons, and the hydrogens on those carbons have been replaced by chlorines and fluorines. So more questions. How is ozone formed in the stratosphere? So high energy or UV radiation breaks oxygen molecules into separate atoms or free radicals. These then react with other oxygen molecules to form ozone. So that's basically what you need to know from what we said earlier on. The equation for dissociation of ozone in the stratosphere is going to be O3 breaking down into the substances that make it up, which would be an oxygen free radical or an oxygen atom and an oxygen molecule, O2. Why is ozone not produced like this in the lower atmosphere? And the reason for that is that there's not enough UV light. Oxygen is not decomposed, so the reaction over there on the left in the orange box can't happen. So some of the effects of causing damage to the ozone layer would be that more harmful UV light is reaching the earth, and this could cause skin damage, skin burn, skin cancer, or skin disease. It could also damage your eyes, and it can cause damage to plants as well. That is the end of this video on the ozone layer. So make sure you take your notes and head over to Teams for any other work that I'll be assigning you on this. So today we are going to look at the last part of this option chapter, which is look at the ozone layer and CFC. So this is your checklist for this part. So looking at